Hello everyone. Today, as I promised, we'll be generating atmospheric electricity, just like I was talking about. Actually, there are two things. One I made myself, and the other I bought at auction. And this is this Tesla generator. So, many will think it's some kind of homemade product. Not exactly. It is, of course, homemade, but this homemade product was, well, so to speak, industrial scale, used in educational institutions. And it was in schools, institutes, and technical colleges for studying so-called atmospheric electricity. So, it's a prohibited technology. Why prohibited? Because it's used here. Of course, it's hard to see on the plate, but when I bought it a few years ago, it was still legible. It's from 1959. Before that, it was widely used. This setup is meant to demonstrate that atmospheric electricity can be generated, grounding, and a similar, well, so to speak, antenna collector. And nothing else is needed for this thing. Then this thing was removed from all educational programs, educational institutions, and it was simply banned. Well, not banned, just banned. And you couldn't even mention it. Can you imagine? I recently watched a video of people climbing a mountain, a so-called very high mountain, and their hair was sparking everywhere. That is, there.
Hair stood up from the electrified air. Experts explain this by the combination of electrical charges in the ground and the air.
We are standing here at the very peak, and the most interesting thing is that you raise your hand and an electric shock starts. And the sound, look, listen, is atmospheric electricity. It's everywhere, and you can capture it. So now I'll put this thing on this tree and climb out. This tree will also serve as a concentrator of atmospheric energy. Plus, it will transmit to this antenna, which, look, by the way, 3 kilograms of copper went into the wire here. At least that's what it said in the material. You need to use at least 3 kilograms so that, you see, yes, energy will accumulate at each end. And this is the so-called collector. This is also a copper tube. There, everything is made entirely of copper. Then, when I install all this on the tree now, you will see how this system works. Back in Vietnam, during the Vietnam-American War, the Americans used trees, huge trees like these, as collector antennas, so to speak, to improve transmission. I already showed it on this tree. Now we have all this, so I installed it. There it is, you can see it standing there. But it's not good. I'll now take a drill a hole and lower a wire from there. Well, that is, you need to drill a hole there to get to the tree's sap. So, this huge tree will act as a concentrator, as an antenna for capturing the energy. See how huge it is. And all this energy, which, well, you know, yes, electric current also moves through the sap, well, through the water. And it will all be concentrated on this antenna. And I will now be receiving all of this through this Tesla installation. We drill as deep as possible, preferably 15 to 20 centimeters. Well, in short, the deeper, the better. So, this time I won't even need a copper rod, because we already have a copper antenna. That is, I will use a real, full-fledged metal ground. This wire here is a ground. It is imperative to strip it here. If you look closely, you can also read ground here. So, this is where we will now connect the ground. And here we will drive our stake. So, let's see. There it is, made of silver glass plates. And this is an adjustable capacity.
It can be replaced with graphene.
Okay, there's nothing there, just in case.
Can be replaced with graphene capacitors.
So, what do we see? That's it. I've connected it to our antenna. And if you watch, there will be a barely noticeable spark, tiny, but I don't think it's even visible on camera. Now I'll move the camera closer. And to achieve maximum sparking, that is, let's show it like this now.
The spark gap
The spark is tiny, the coil and capacitor are not tuned. We can see that, right?
Spark gap can be replaced with a sealed one.
That is, the coil is variable capacitor, variable inductance, and variable capacitor. Because of this, there is almost no spark. So, essentially, this system doesn't work. What needs to be done to make this system work? This system will work under conditions where there is resonance. We'll do all this now and show you.
Tuned to 50 SWR.
So, we achieve resonance. Change the capacitor.
50 ohm. So the spark gap can be replaced with a sealed spark gap in a vacuum or a gas medium, and that will make it quiet when it operates and somewhat safer and more efficient. The spark gap is just a reflection of a pressure release of electricity. The capacitor shown here is glass dielectric with silver membranes or a mirror. The membranes individually of silver are connected to the slide so that as he pulls the rod, it will adjust to add more and more or less and less capacitance. What he's doing is tuning the standing wave reflection. He's matching it to the ohm reading of the antenna that he has. Typically in radio, this is set at 50 ohms. So once he adjusts that capacitance, he's reducing the standing wave reflection, and the power starts to fill the capacitors, and then the pressure release showing it's full comes on the spark gap. On the left side, you can then connect a switching power supply, a rectifier and a regulator to make the power be put to use. This could mean a second bank of capacitors, and then a regulator, rectifier, switching power supply from 12 volts, 24 volts, 48 volts, or DC to DC. You can of course step it up, and you can use various voltage multipliers in that circuit there as it's going to a load. The load should be a separate battery or capacitor bank. The objective of this is to show that you just have a constant charging device. Whilst the capacitor shown with the glass and the silver can run loads, we are now more advanced and able to connect downstream load management much more efficiently. The performance of this unit shown can improve greatly with graphene coated nano carbon wire and graphene capacitors in place of what's shown with a sealed spark gap. Likewise, the antenna can be replaced with a rectenna. The advantage of a rectenna is it has the capacitors and diodes on the antenna. So you build up much more charge at the antenna in a one-way configuration, in a compounding configuration, and then that voltage is then sent to your coil. The coil is a simple coil. As shown, it has a ground and it has an output and an input. There's an adjuster there on the output to the capacitor, simply to give you another part of adjustment. You can take measurements with modern equipment, and it would be wise to start at 50 ohms across all components, as you will match the standing wave reflection. But it should be noted, it is not the only ohm rating that can work. This is a device which is high voltage. In a lot of ways, we can pull power from the ground as well in this circuit. So it's best to look at it not as only atmospheric, but also the flowing electrons through the earth. This is another reason why you have another tunability that's not shown in this video. You can put a one-way diode on the earth so that the electrons can flow to the capacitor. It sounds reverse for most engineers to do that, but then you have tunability on that ground wire. So another way to do it is throw safety out the window. You're extracting electrons from the earth, and you can put a coil and a tunable variac on the earth with a one-way diode to the capacitor, letting electrons from the earth to the capacitor. This would be what I call stage 2. You can also replace or parallel the capacitor shown with a nanocrystalline core with primary and secondary, and you can also RF loop back both from the initial coil from the antenna, also from the nanocrystalline core, so that you in effect are catching the RF and using it as a charge. So you're concentrating the gathered electrons from the antenna and from the earth and storing them in the capacitor, having tunability, and then magnify them greatly in the transformer downstream. I hope this helps everybody.
Oops, look, that's it. Resonance has been achieved. Look, it works. The system has just entered resonance. Look, that is, even the necessary capacitance is already there from the start. Look, I just changed the capacitance, or rather the inductance initially. I just changed the capacitance and the system worked. Here's a miracle of resonance. Look, a miracle of resonance. I'll show you again. Our antenna is coming, and there it is. There it is, the original one. I hope you can't see it well. Here's the grounding. That's it, just the grounding. Well, of course, I needed to wet it. There's nothing around the clearinghouse. Here's the general system. Now we'll even try to light a light bulb. That is, we need to make an energy transmitter. Well, that is, like install a step-down transformer. And now this whole system will be there. I'll show you how the transmitter works. Now it also needs to be brought into resonance. And you'll be shocked. Here's a forbidden technology. What they said, this device was confiscated in 1959. Since then, it's been used in schools to study atmospheric electricity, to show the energy around us. It was banned, I repeat. So, this technology was banned. Okay, now we'll install this thing, a Tesla coil for transmission. Oops. At the same resonant frequency, everything starts working. That's it. Okay, well, let's try hundreds, maybe tens of thousands of volts, only here. There's no reaction here, only here.
So, in effect,
There.
That's like an RF loopback right there. Except that
In theory, this system should work, but for some reason it doesn't.
he's not connecting it back to the circuit.
Okay, I'll set it up next time and I'll show you.
Those coils are RF coupling.
The next video will be of me filming. Well, that is, this light bulb, it's actually small. It's from a 220 volts refrigerator, and it will light up this entire system.
So
That is, not only is this energy-saving bulb lit and working, but it will continue to work.
So on the board you have a primary, and then in the center of the primary you got a secondary.
Everything else is still like this.
And then that's creating RF.
So, you don't think that it's impossible to extract energy.
And then the bottom coil is coupling. And then radiating from
That
the top.
is, I'll adjust this so that the spark here gets stronger, and here it gets weaker, or vice versa, when we change the frequency.
And so to tune the coils together, they've all got to be
Well,
at 50
that's
ohm.
it. The entire system.
The tower, transmitter and receiver tower won't talk if they're not 50 ohm and have zero standing reflecting wave. So in that you see he didn't have an adjuster on the receiving coil tower. So he's put the position of the tuner on the coil and then put the tower in the center of the coil, and he doesn't really know what ohm rating he's at that transmitter tower that he's added. And then he's put the other tower there and said it's not sure, it's not syncing up, and that's because he's got to have some sort of a tunability and measurement. So as you can see, both don't have standing wave reflection, because once that gets in line at 50 ohms as an example, that standing wave reflection will be minimized, and then you'll get maximum power transmission or radio transmission. So maximum RF, maximum send RF, maximum receive RF, maximum power sent, maximum power received. So we did this with cells as well. We did it with the nanobubble water fuel cells using coils wirelessly. So we had wireless nanobubble water cells working. So I just make a note for you guys to see the same things that everybody else is seeing and building. And you can see the simplicity of the tunability, and you can also see why it's so important to not only tune the circuits to the transformers, but also the transformers to the antenna, or the transformers to the cell. And the way you bring back the ohm reading is with the capacitors. So when you add capacitors, or you add capacitors and divide them on a circuit, basically what you're doing is lowering the ohm reading down to 50 ohm to match your transformer and match your circuit. Doesn't matter if the circuit's a coil or if it's a PWM. All that's going to happen is that if you don't have any way to bring the ohms back, you're going to get a standing wave reflection And a lot of people see that as back EMF or back spike. Well, that's not, you don't want that. You want maximum going to the load or to the cell or to the caps or to the battery bank. You can add, obviously you can add many modern devices for PWMs with gates and things like that, but if you master this basic method and then you modernize it, just simply changing things to graphene coated copper and graphene capacitors, it's like 100-fold increase in performance. So no matter all the other things you might do, that's the heart of it. You can of course add nanocrystalline step up, step down transformers. You can add more caps, more batteries, power inverters, rectifiers, regulators, PWMs with gates, paralleled PWM with gates, voltage selectors, PWM selectors, transformer selectors. You can scale it to 10, 20 transformers in parallel so that you have multiple loads, and you can also put them in series if you really want to go crazy and make a robot killer or something. So these are very interesting things, and I think that over literally hundreds of years, and now 20 years of high technology, it's becoming a little bit easier for people to, if you've studied it for so long, you can see the shortcuts. And so the shortcuts are just so simple. You must get the foundation right, you must get your spark going, you must get your resonance going, you must get your SWR to a minimum, you must learn and improve your antennas. If you've got capacitance and diodes on your antennas, you're going to have a higher performance to the coil as receiving. If you have knowledge of diode and the coil on the ground, you can tune the ground. And basically all these things just magnify what he's showing in the video, and they magnify it by 100 or 1,000 times. And so as far as recharging batteries and caps for doing work before transformers are added, it's very competitive against solar. And it's completely parallelable and scalable, daisy chainable. And the reason this video is so important is he's made it from wood, copper, glass and silver. You can get that pretty much anywhere. Even you can use aluminium foil in replace of the silver foil. Even you can use other types of copper sheet or conducting sheets of thin metal between the glass plates. They'll all work as capacitors. And it doesn't take much research or thinking to work out that you can put fat between the glass plates. That will also work. Fat with graphene powder will also work between the plates. Graphene plates between the glass will also work. So this is a foundation which you can do many variations. You could use silicon substrates between the glass. You could use various crystalline pastes between the glass. You could even use biofilm between the glass, so bacteria is making electricity there as well. So if you map it out, a combination of these various things in maybe 2 or 3 types of capacitor banks would really make it rock solid. You could have a bio cap bank, self-charging. You could have a nanocrystalline core, self-charging. You could have a glass silver capacitor, self-charging. And you could have silicon substrate with magnesium zinc paste, self-charging capacitor. So there really is no reason why people shouldn't just be building these now and connecting them to cap banks and then connecting them to regulators and charge controllers to recharge their batteries. Once you have that power set at 24, 48, you have quite good power density to be able to use modern equipment to charge. You can connect it straight to a Victron controller, and you can, see everything with Bluetooth and see its charging rate